Welcome to my presentation. This is my presentation of my capstone project for Computer Science 400. It's called Design of a Robotic System for Teaching and Research. Here's the overview. I'm going to talk about my goals, my motivation, why I picked this robot, and talk a little bit about the tools that I used for it. I'm going to give an introduction very briefly to robotics, and then I'm going to talk about the design of my lessons and the website that I created. So, the goal of my project was to create a website to help introduce people to robotics and STEM. And for this, the website I planned it to include some of the features are that it's easy and fast to navigate. It includes individual pages for each course that are easy to navigate, and then all the lessons follow a similar structure that I'm going to talk about in a little bit. And at the end, I included code-along videos and demonstration videos to show how the program is supposed to look like if it works correctly. And also it's downloadable under a GitHub repository in case people want to download it and make sure that it works. So why is robotics important? This is part of my motivation because I consider that robotics is an industry that is growing every day. It's going to have an impact in our daily life, including both work and home. And I think it can have a positive impact in everything that we do and basically how we operate by improving our efficiency and providing better levels of service in general. Uh, Also, viewed from an educational point of view, studies suggest that robotics could be beneficial in introducing STEM to people because apparently people are happy when they work with robotics and they like seeing immediate results in what they're doing. And the MBOT it's a particularly good tool that you can use for with this objective. So, also as part of my motivation, I took a quick analysis about the percentage. Well, this is a report that I found. My sources is right here. Um, and they basically say that across the United States, only about on average 51% of public high schools offer a foundational computer science course. And as you can see in the map, Connecticut is actually among the best states to offer foundational computer science courses for high schools. However, the rest of the states are somewhere in between, most of them, 0 and 50%. So that's still not a lot, especially if we take a look and regionally. Although Connecticut is among the top 10 states, if we take a look, for example, to these numbers right here, there's 6,759 open jobs that are open each month for computer science, and only 564 computer science that graduated in 2018 in Connecticut. And that's a big disparity. So that basically shows why we need more computer science students and introduce more people to STEM. If we take a look and the diversity wise, if we take a look into race, most of the computer science students are white, and all the other minorities only compose about 34%. And gender wise, it's very similar. Male students are 73.1%, which is a strong domination in the field, and only 22% are female. So it's important to include more people from different backgrounds in our industry. If you want to take a look more deeply into this kind of motivation, I'd recommend you to take a look to this report, which is 2021 State of Computer Science Education Accelerating Action Through Advocacy. And that's, I think, for Connecticut, actually, in particular. Or you could also watch the TED Talk by Ashley Gavin. I think she summarizes very well what I just explained. So the point of the MBOT is that it's a robot that it's very good to it's a very good way to introduce beginners to robotics, electronics, and sensors. And it's especially very good because it's easy assembled and it's affordable and it's compatible with two coding languages that are simple, which are Python and Scratch. In this, I hope I didn't need to explain what Python is, but Scratch is actually an educational coding language that was created with the sole purpose of being easy to understand, and it's block-based. And although in this comparison that I make, I'd like to say that although my project is based on Scratch, but it's also compatible with Python, and Python could help people learn and go beyond robotics because Python has purposes beyond just robotics. For robotics, very, very brief introduction. Robotics is an interdisciplinary branch of computer science and engineering, and the objective is to create robots that help and assist humans in operations to make them more efficient and basically also eliminate any dangerous situations that could involve humans. They have a lot of applications. As you can see here, for example, they have medical purposes. We can see surgeons performing operations um, across the country, assisted by robots. We have the famous Roomba as well, which is a vacuum that it's a robot. We have the Mars Land Rover, which helped us explore Mars. We have military robots to help us detect landmines, and of course, we are using them a lot in manufacturing. But for now, we're going to focus on the educational robots, which is the MBOT. The MBOT has many advantages over other educational robots. First of all, it's very affordable if we compare it to other robots that are also educational. And most important, most of the tools that we use on software wise are free, are also developed by Mblock and are based on Scratch. Um, However, another good point about the MBOT is that it's a robot that has applications that are just beyond educational. There's multiple expansion packages that the Mblock, the company that created the robot, has and sells that allow you to give it multiple purposes. Now, this is part actually of why the embed is a good use in education. This is a study that was made, which basically shows the levels of interest of multiple students before and after a workshop that used the embed. And as you can see, in general, there was a increase in interest, which shows that maybe the embed is a good tool to introduce people to STEM and robotics. So now for the hardware and software overview. This is basically the main chip of the MBOT. We have our RJ25 ports, which are used for our sensors. We have our motors ports, and then we have multiple uh, sensors that are already implemented in the chip, such as the light sensor that I use in one of the lessons, and the IR receiver, which is for remote control, for example. Among some of the sensors that are included, we have the ultrasonic sensor, the line follower, and as you can see in this deconstruction of the MBOT, you have your chip and it's very, very easily assembled. For the software overview, there's basically three main software tools. The MBlock, which is available for desktop version and an online version, and then for mobile, there's Blocky and MakeBlock. I think Blocky is the only one that's different. That one allows you to control the MBOT more like a remote robot. However, the other two are used mostly for coding using MBlock, and which is an interface that allows you to program using Scratch, which is, as I already mentioned, an educational coding language developed by a professor of the MIT with the sole purpose of being educational. This is what it looks like when you first open the interface. However, in my lessons, I work mostly on Arduino mode because it allows you to see what's going on the right hand right here, and allows you to see how your code is translated into Arduino C. Now, for the website, this is basically the homepage. You have your navigation bar, which is very simple. And then you also have your individual courses sections, which basically describe very briefly what the course is about and give you a link to it. Once you click into one of them, this is what an individual course main page looks. And all it has, it's a description of the course and a list of all the lessons that I included. The lessons have a collapsible section that introduces the lesson very briefly, and then it gives you a link to the individual lessons, which are these. They have a general structure that I'll talk in a little bit, but basically it's a structure that follows the waterfall model, and they are all the same, so the students can see a pattern that's easily followed. This is how I worked. I basically went in order for all the lessons in recording, coding them, and writing about them. Writing, coding, and then recording. That's how I did it. At the end, I just submitted my presentation and report, and then went through the process of giving it to my professor and making revisions. For the lesson general structure, it follows the waterfall model in which you have to define your objectives, analyze them, then design them using either pseudocode or flowcharts, and then implement it. And at the end, of course, it's the testing to make sure that everything's working correctly. The lessons are organized in a way that goes in increasing difficulty as I perceived it. The ones that are in red are things that I came up with myself, and the other two that are in yellow and the ones that are in black are, well, they're all based on a book called A Gentle Introduction to Robotics by Charles McKnight. But the ones that are in red are basically the ones that I came up with. Um, to talk about my lessons, I'll talk about it very briefly. So this is an example to see what an individual lesson is like. So first, the presentation of this lesson that I talk, which is called traffic simulation. And this is one of the last lessons in which I combine most of the elements from previous lessons to create programs that a program that it's a little bit more involved. So in the objective of this one is to simulate the behavior of a person driving a car, in which basically the mbot has to react by following a path like it's driving, and then reacting to, for example, a missing section which represents a stop sign or an object in the way. To do this, it uses the line follower values, and it also uses the ultrasonic sensor at the same time. So now, for my objectives and requirements, it uses, as I already mentioned, the LED lights, line follower, and ultrasonic sensor. And the objectives are to follow a path, detect objects in the way, and interpret missing sections in the path as like a stop sign or a crosswalk, or like someone is crossing, and then to stop and basically react like a person would if there was a car. To complete this lesson, I had to use all the information from previous lessons and all the codes. And using what we know from the ultrasonic sensor, I programmed the mbot to detect objects at the same time while it's moving and stop if there's something in the way. Now, this is basically the design, what it looks like using the values. I cannot explain this without going much into detail about how the ultrasonic sensor works. But once that's analyzed in previous lessons in my course, and once you can understand the analysis, you can basically code this, and this is included on the code along and the downloadable code. This is basically the lesson. This links to a video, but because of time constrictions, I will not be able to show it, but that's what it looks like. So tasks that were implemented, I used the line follower, I used the object detection, and something that I call the stop strategy that fires once there's a missing section or a object in the way. So in the other lesson that I created, it's the self-parking. The presentation is very similar. It performs very similar tasks as the last lesson, and it actually uses the same things for the requirements. However, one thing that I'm going to talk about in this one, it's that once there's a missing section, instead of using the stop strategy, what it does is that it fires something that I call find parking spot strategy, which I'm going to talk about next. It uses basically also the missing section to fire this strategy, and it uses all the code from the last lesson. So doing the traffic simulation lesson, it's a pre-requirement, and then using a few trial and error, you have to calculate how to turn the mbot 90 degrees and 180 degrees to different sides, and which is a little bit difficult because the motors of the mbot don't allow to do this very accurately. But once you can do that, you can use this strategy, which is basically turn to the right, check for a parking spot free. If not, turn to the left, and if there's none, basically go back to its original path and keep going until it finds a parking spot. The design, once again, it's based on the last one, but adding more features to that and building on top of that. And this is the code. Once again, the code it's uploaded on YouTube on my on the lessons, but because of time, I cannot do this anymore. Um, so here's a few links to the lessons. They're all on YouTube, so they're accessible beyond the website. And to talk lastly about my outcomes from this project, I learned about the importance of robotics, how it can be applied in real life. I learned how to design basically programs and missions, and I had never worked before with robots, so this was a first time as well for me. And how to apply all the concepts that we learned about software development using the waterfall model was also something that I learned here, and something that I think is going to be very useful in the future. It's how to use LaTeX to write professional reports. Um, I consider that there's many things that I learned, mostly how to push myself. uh, Before doing this, I wasn't sure if I was going to be able to create something like this, because nothing involved any, in my college experience, nothing used Scratch or something like that. So I learned how to use that and how to be a self-learner and push myself beyond my own limits. It was a big challenge because I self-doubted on every step, but with the help of my professor, I was able to move on. And however, I consider that most of the challenges that I faced were I got through them thanks to talking with my professors about what I had to do, and basically just trying and making a lot of mistakes. So, in conclusion, it is important that we help people introduce and not be afraid of STEM as a topic, because it's necessary for our future, since it's a STEM and coding, robotics is our technologies and industries that are growing every day in our modern world. And as another personal goal and next step for this project, I'd like to translate it to my mother language, Spanish, which would also open this course to a bigger and wider um, uh, public who doesn't speak English, and make it more accessible. For a future of this project, I'd like to maybe publish my work as a significant paper, what work with Dr. Shida on this new mission, and probably find or try to find a career in robotics and artificial intelligence. This is my references, and that would be the end of my presentation. Thank you very much.